All right, today we're going to be solving equations using multiplication and division. The division property of equality states that two sides of an equation remain equal when you divide each side by the same non-zero number. In other words, when you divide on each side of the equation, you cannot divide by zero. Let's take a look at example number 1. Example number 1 on page 448 says 20 equals 4 times x. We know that when we solve equations with addition and subtraction, we want to get the letter or the variable by itself. Well, the same goal is here as well. We want to get x by itself. Notice that x is on the right-hand side of the equal sign. We're going to make sure that it stays on the right hand of the equal sign, but we're going to have to get rid of everything that is with it. So right now, we got to get rid of multiplying by 4. The opposite or inverse operation to multiplying by 4 is dividing by 4. So that's what we're going to do. We're going to divide by 4 here on the right-hand side. Well, in order to keep our equation balanced or equal, we also have to divide by 4 on the other side of the equal sign as well. This is what the division property of equality says. On the right-hand side, 4 divided by 4 equals 1. Well, we don't write 1 times x because the multiplicative identity property says 1 times any number is that number. So we will just write x instead. Then on the left-hand side, 20 divided by 4 equals 5. So x equals 5, or 5 equals x. And if you want to at this point, you can turn it around and write it this way, so that x equals 5. It says solve negative 8y equals 24 on example number 2. Negative 8y equals 24. Notice the y variable is on the left-hand side this time. So we need to get rid of multiplying by negative 8. The opposite of multiplying by negative 8 is dividing by negative 8. Whatever we do on the left-hand side must also be done on the right-hand side, so I'm going to divide the 24 by negative 8 as well. Negative 8 divided by negative 8. Notice how the signs here are the same. When you multiply and divide, you want same signs because the rule for multiplication and division with integers is same signs positive. When we get done, we want our variable y to not have a negative sign in front of it. Dividing negative 8 by negative 8 means that when I divide that, it's going to equal positive 1. So we get 1 times y, or just y. 24 divided by negative 8, those signs are different. So I'm going to get a negative answer because in multiplication and division, different signs negative. And 24 divided by 8 is 3. So y equals negative 3. When we use multiplication and division to solve equations, we want to have same signs on the side with the variable. So if I'm multiplying in my equation by negative 8, the opposite of that would be to divide by negative 8. When you multiply and divide, you don't want to use the opposite sign. You want to use the same sign. And we'll continue to emphasize that as we go over these problems. Layla sent 574 text messages last week. On average, how many messages did she send each day? So, first thing is first, we study the problem and ask, what is this question asking me? And it says, how many messages did she send each day? Well, we need a variable to stand for that. So they've written here, let M represent the number of messages Layla sent. So you would write on your paper, M equals number, hashtag, of messages. Then we need to go back and look at what facts they have given us. Layla sent 574 text messages last week. Okay, I need to come back to my variable because this isn't specific enough. It says number of messages, and it's actually the number of messages each day. So we need to make sure that we are being specific enough. So she sent 574 text messages last week. So if she sent 574 last week, and we want to know how many she sent each day, then what do you think I should do to the number of messages each day to get 574 for the week? Hopefully some of you are thinking, oh, there are 7 days in a week. There are 7 days in a week. If you sent M messages each day and you multiplied that by 7 times the number of messages you send each day would give you the total number of messages you send in a week. So 7 times M, 7 days in a week, times M messages per day equals 574 total messages. Now I've lined up a plan to solve this problem. So now I can use my division property of equality to divide both sides of my equation by 7. So I want to divide by 7 on both sides. 7 divided by 7 equals 1. So I have 1M. And 574 divided by 7. 7 goes into 57 8 times. 8 times 7 is 56, leaving me with 1 left over. And then 7 goes into 14 2 times. So we end up with 82. And we got to go back and say, okay, what is M again? M is the number of messages that Layla sent each day. So this is 82 messages per day. So let's go on to example number 4. The multiplication property of equality states that 2 sides of an equation remain equal if you multiply each side by the same number. Okay, sounds exactly like the other properties we've learned so far. So let's use that property on example number 4. It says A divided by -4 equals -9. Again, our goal is always to isolate the variable, to get the variable alone. And so the variable is on the left-hand side. We want it to stay on the left-hand side. So we need to get rid of this dividing by -4 by doing the opposite of what we see. What is the opposite or inverse operation of dividing by -4? It is multiplying by -4. And again, when you multiply and divide, you want same signs. So we're going to multiply by -4. So whatever I do on one side, I must also do on the other. So a -4 divided by a -4 equals a +1. Same signs positive in division. So I get 1A, but of course we only write the A because of the multiplicative identity property. And then over here, same signs again with -9 and -4. So again, we're going to get a positive answer. So we just do 9 times 4, which is 36. All right, let's take a look finally at example number 5. The distance D Tina travels in her car while driving 60 miles per hour for 3 hours is given by the equation D divided by 3 equals 60. How far did she travel? I want to point out that this has distance. It asks how far did she travel? So that's again distance. I want to point out this 60 miles per hour. We call that a rate. And then 3 hours is a time. You're going to see these types of problems creep up over and over again, where you have distance, rate, and time. And there are some formulas that are noted on page 450 in your textbook, that distance equals rate times time. Distance equals rate times time. That's the formula we're using here in this problem, except they don't have distance equals rate times time here. Instead, they have distance, they have, and it's backwards, they have distance divided by time equals rate. So be aware that in this problem, we're using a formula. Distance divided by rate equals time. And I just said that wrong. So be aware that in this problem, we're using a formula that says rate equals distance divided by time, except they've got these two sides reversed. So our rate is 60, and they've got it on the right-hand side. We don't know our distance, that's why they have a D, and 3 is our time. And if you look back in the problem, 3 hours is the time, 60 miles per hour is the rate, and we are looking for D, the distance. So D equals distance. So let's go ahead and solve this problem. We see D divided by 3 equals 60. What will we do to get rid of dividing by 3? We need to multiply by 3, and we need to do that on both sides. So multiplying by 3 on both sides. 3 divided by 3 equals 1, so those cancel out, leaving me with D. And then 60 times 3 is 180. And again, 180 is a distance, and since our rate was in miles per hour, this distance would be 180 miles. Okay, so that was our final example. There is no letter problem for example 5, so I will turn you loose to do A, B, C, D, E, F, and G on pages 448 and 449.